Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on capacitance from October-November 2021 Paper 4 Variant 2. In this lesson, we will discuss what is electric potential, means how we can define electric potential in a right way. Then we will talk about calculation of capacitance of an isolated conducting sphere. At the end of the lesson, we will also discuss how to calculate charge transfer between two spheres. For part A, we need to define electric potential. Let's try to understand this one with the help of point charge. So this one is over point charge, means the size of this one is very small. And imagine that the charge on this one is positive. And we take another point, and this point is located at infinity, means very far away from this point. And we have one unit positive charge at this point. This is our test charge, and test charge in electricity, by convention, we always take unit positive charge. So this is unit positive charge. Now, if we move this unit positive charge to a point P, and imagine that the distance between these 2 points, let's say the distance between these 2 points is equal to small r. Mean the distance from the center of this charge to this point is equal to small r. If we want to move this charge to the left, we have to apply force on this one. In this case, there is one electric force that is acting to the right. This is a repulsive force because this positive charge will repel unit positive charge. So we have to apply force this way. And these two forces are almost equal in magnitude. Means the speed of the charge at this point was equal to 0. We are just talking about extreme case. And when bring this charge to this point, its speed again has to be 0. Means there is no gain in kinetic energy. Or simply we can say in this case there is no change in kinetic energy. So now if you look at this one, in this case external force, I will simply say F external. The work done by this external force is positive because the charge is moving to the left and external force is also to the left. So simply we can define now the potential at point P. Potential at point P simply is equal to work done by external force, or we can say work done by external agent. External agent means it can be you or it can be anything which is applying force on the charge to the left by external agent per unit positive charge. So this is how we can define potential at any point per unit positive charge. In this case, potential is positive because this work done is positive. And if this charge was negative, then we have to apply force to the right and charge will be moving to the left. So the work done will be negative. So the potential of negative charges is negative. So simply we can say positive charges, the potential is positive, and negative charges, the potential is negative. Positive charges, the potential is positive. So simply we can write down positive charges, the potential is positive, and negative charges, the potential is negative. Very important point. If charge is positive, its potential at any point is positive. If the charge is negative, its potential at any point is negative. Now let me show you how you can write down a proper answer for this question. This question has 2 marks and this question is very common in past papers. You need to understand how to define electric potential in a right way so you can get 2 marks. This is how you can write down your answer. In your answer, you have to mention 2 points. The first point you can mention work done per unit positive charge. If you write down this one, you will get 1 mark and that is B1 mark. And the second mark you will get if you have mentioned bringing from infinity to a point. If you bring unit positive charge from infinity from this point to any other point. So the work done to bring this unit positive charge from infinity to this point is called electric potential. Or simply you can say work done per unit positive charge to bring the charge from infinity to a point. So this is how you can define and you will get 2 marks. For part B, it is given to us an isolated conducting sphere in a vacuum has radius small r and is initially uncharged. It is then charged by friction so that it carries a final charge q. This charge can be considered to be concentrated at the center of the sphere. Means we can treat that one as a point charge. By considering the electric potential at its surface, show that capacitance of the sphere is given by this equation. Epsilon naught is the permittivity of free space. First thing question is asking us to calculate capacitance. See, capacitance is equal to Q over V. Q is the charge at the surface of the sphere and V is the potential at the surface of the sphere. So V is the potential. Now imagine that we have sphere here and the charge on its surface is plus Q. We need to find out what is value of V at this point. So if we have value of V at this point, simply we can plug in this formula and we can find out value of C. V for any point charge is equal to KQ over R. So KQ over R. R is the radius of the sphere, mean the distance from the center. So this is R. But we have to plug in value of K. K is equal to 1 over 4 pi epsilon naught. So simply we can replace K with its value. So we can say Q over R and K is 1 over 4 pi epsilon naught. Simply we can write down V is equal to Q over 4 pi epsilon naught times R. Now we simply need to plug in these values here. So we can write down here Q over Q divided by 4 pi epsilon naught times R. Simply we can write down Q multiply 4 pi epsilon naught R divided by Q. Then we can cancel this Q with this Q. So we left with 4 pi epsilon naught R. So this is the value of capacitance. So if we have a charged sphere and we need to calculate the capacitance of that charge conducting sphere, so simply we need the radius. So the capacitance is depending on the size of the sphere. If the R is greater, it means capacitance of that sphere is greater. It is not depending on other factors because pi is constant, epsilon naught, permittivity of free space, that is also constant. So this is how we can prove that C is equal to 4 pi epsilon naught times R. This question has 2 marks. The first mark you will get if you have written C is equal to Q over V. So this is first mark and this is C mark, you will get 1 mark. And if you have derived this one, you will get answer mark. So this is answer mark. If you have derived this one, you will get 2 marks. For part C, it is given to us the dome of an electrostatic generator is a spherical conductor of radius 13 centimeters. It is initially charged so that the electric potential at the surface is 4.5 kilovolts. So simply we can sketch this one. So this is dome of generator and the radius of this one is given, that is equal to 13 centimeters and the potential at the surface of this one is equal to 4.5 kilovolts. So we can say this is V1. It is also given to us a smaller isolated sphere of radius 5.2 centimeters is initially uncharged, is brought near to the dome. Sparking causes a current between the two spheres until they reach the same potential. Very important point, same potential. Assume that any charge on a sphere may be considered to act as a point charge at its center. Means we can treat sphere as a point charge. Calculate the charge that is transferred between the two spheres. So first of all, we have dome that has potential 4.5 kilovolts and we have an isolated smaller sphere and this has no potential. Initially it has no charge, it has no potential. The radius of this one is given, that is equal to 5.2 centimeters. We bring these two together, means we bring them closer to each other. Then these two spheres, they have the same potential. So this one is the dome of generator. Radius of this one is 13 centimeters, and the smaller sphere, radius of this one is 5.2 centimeters, and they are at the same potential. Means the value of V here, the potential at the surface of dome and the potential at the surface of small sphere is the same. So potential is the same. We have to find out how much charge is transferred between the two spheres. It simply means that how much charge flow from bigger sphere to the smaller one. So simply it means that how much charge go from bigger to the smaller sphere. Let's say the charge transfer is equal to small q, and the total charge initially on this one, let's say, was capital Q, and the charge on this one is equal to 0. The charge remaining on this one will be capital Q minus small q, and we need to find out what is value of small q, mean how much charge is transferred between these two spheres. So first of all, we need to calculate charge on big sphere. Q is equal to CV. C we have already calculated, that is equal to 4 pi epsilon naught R times V, the potential at the surface of sphere. Now simply we need to plug in values. We have 4 pi, value of epsilon naught is 8.85 times 10 to negative 12, and the radius is 0.13 meters. We have converted into meters now, and the value of the potential at the surface is 4500. If we do this calculation, we can find the value of charge at the surface of sphere. That one will be equal to 6.5 times 10 to negative 8 coulombs. So this is the value of capital Q on the surface of dome. Now we need to calculate amount of charge transfer, but it is given to us potential is the same. So simply we can equate, we can say potential, let's say this is V3 and let's say this is V4. This is equal to V and this is also equal to V. So in this case we can say V3 is equal to V4. So V3 simply is equal to K capital Q minus small q divided by the radius of the sphere, and this will be equal to K small q over, so we can say this is R3, let's say this is R4. So we are talking about this is R3 and this one is R4. So we can cancel this q with this q. Now simply we need to plug in values. Capital Q, we have the value of capital Q, that is 6.5 times 10 to negative 8, minus we have small q, and this is divided by radius of the sphere, that is 13 centimeters. So this means 13 times 10 to negative 2. Here we have small q, and this is divided by 5.2 times 10 to negative 2. So 10 to negative 2 we can cancel with 10 to negative 2. Now simply we have to solve for q. So in this case we have 6.5 times 10 to negative 8 minus q, and this is multiplied by 5.2, and this is equal to 13q. Now we can simplify this one for q and we can find out final value of q. Final value of q will be equal to 1.9 times 10 to negative 8 coulomb. So this much charge is transferred from the dome, means from big sphere to smaller sphere. So this is our final answer, 1.9 times 10 to negative 8 coulombs. And this question has 3 marks. The first mark you will get if you have got the right value of capital Q. So this is C mark. You will get 1 C mark. And the second mark you will get if you have written this formula. So you will get the second C mark. And the last mark is answer mark. If you have got the right answer, you will get the last mark. So this is how we can approach this type of problems.